Um, this question comes under simultaneous equation mostly, that reads a two-digit number is such that the sum of the unit digit and the tenth digit is 10. If the number is reversed, or the numbers are reversed, we talk about the numbers are reversed, when the digits are reversed, then the number formed exceeds the original number by 54. Find the number. So here you just ask about that. You should find the number that we are talking about. And if the first statement says it is a two-digit number, so a two-digit number, it means that it can be a number that is from 10 and not exceed 99. So from 10 is 1 and 0, that is two digits, up to 99, which is 9 and 9. So if we go to 100, that is a three-digit number. When we go from 1 up to 9, that is a one-digit number. From 10 to 99, it's a two-digit number. So when you want to get a two-digit number, so it can be, we can say, for example, maybe the number is 25, for example. So this is a two-digit number. So they're saying that a two-digit number is such that the sum of the unit digit can also be used to describe ones. We have ones, tens, hundred, that's a place value. So if the number, if the unit digit, if we add the sum of the unit digit and tens digit is 10, then we can say that these numbers, for example, they might not be the same. So in algebra, the numbers that are not the same, we can give it that is x and y, because they are not the same. If they're the same, we can put it xx. But in case of this, we don't know them, so we give them unknowns. That's the reason why it will bring about the simultaneous equation. So we take, for example, we have this one at x and y. So they're saying that the sum of the unit digit and the tenth digit is 10. So the unit digit is this y when you add with 10. So we can have x plus y. We get our answer to be 10. So when you add the digits, unit digit and the tenth digit, one's digit and the tenth digit, when you add them, you get 10. So this one gives us the first equation. So the first equation. So another statement says that when the numbers are reversed, for example, I give the example when you have 25. This 25, 5 is the unit digit, then 2 is the tenth digit. Therefore, if I want to get this 25, it should not be 2 plus 5. It should be 2 times 10, because this one is the tenth digit. So it becomes 20. Then after getting that 20, I add to the ones digit. When I add, I get 20 plus 5, which will bring for us 25. When we reverse the number, we will not do the same. We will again do the same, whereby we will have now 5 times 10 plus 2. And the reverse number for this one, for 25, will be 52. So when we reverse it, it's supposed to be forming 52. So the correct number for us to get 52 using this method will be 5 times 10, which gives us 50. Then we add 2, bringing for us 52. So therefore, we add this one to be x and y, where y is our ones digit or unit digit, then x is our tenth digit. Therefore, we can say that the original number was 10 times x, giving us the number itself. Then we add the ones digit, which is y. So this one gives us 10 x plus y. And remember, we cannot add them because they are different what? They're not like terms. Let me say so. So what we do, this one is the original number. So I say if the number are reversed, the number formed exceeds the original number. So when we reverse the number was now 10x plus y, which is x and y. So when we reverse number will be now y and x. Therefore, for us to form the number itself, or the different number, so we'll have y times again 10 plus x, so that we don't have the same to bring for us the issue of the simultaneous equation. So y times 10 will get 10y, then plus the x. So when we add this and this, we get the number when it is reversed. So therefore, when you have that, now you are told that if the number are reversed, the number formed exceeds the original number by 54. The number formed exceed means more than. So when you take maybe we can do it in two ways. One, we can say that 10 plus y, when we add 54, it will be equivalent to this. So when you take 10, for example, we have now, we have 10, now we have 10y. This is the number formed when we reverse 10y plus x. Exceeds the original number by, so when you take away 54 here, because it's the final, because this one exceeds the original number, there was the original number by 54. Therefore, when you take 10y plus x minus 54, this one is the same as the original number which we have, which is what? Which is 10x plus y. So we get 10y plus x, then minus 54 is equals to 10x plus y. Therefore, we can use this one to collect the like terms, where we see that now when we have 10y, we can bring this y this side. And remember, when we normally bring it and it crosses equal sign, it becomes a minus, because here we have a plus. When it is a plus, it becomes a minus. When it is a minus, it becomes a plus. So it will be 10y minus y. Then again, we can say that we have this 10x this side. You can bring it close to this to form an equation. So we'll bring this 10. When you bring it, we have here, we have already plus x. So when you bring the 10y, it becomes minus 10x. I mean 10x. So is equals to, now we can take this 54. We take it the other side. It will as well pass the equal sign. So it will be positive 54. So therefore, we have now formed our equation, number second equation. Second equation will be 10y minus y. So we will have 9y, then plus x minus 10x. It's like I have a date of 1, because this is 1x, a date of 1, then another having a date of 1. I have 1, then I take a date of 9, which means I'm a date of 10, which means I will be having a date of 9. But it's a 9 what? 9x, which is equal to what? 54. So therefore, if you look at the number itself, you can do something called simplification, where we have 9y minus 9x 54. So we thought that 9 is common in all numbers. 9 is common here, 9 is common here, 9 is common here. So what do we do? Divide by 9, divide by 9, we divide by 9. So that will remain in the simplest form. So this 9 goes to 9. You have y minus this, and this will be minus x is equal to 9 goes here 1, 9 goes here 6. So we have 6. So therefore, we will treat this one as our second equation. Remember, our first equation was x plus y is equals to 10. So that was our first equation. The second equation now, y minus 10 is equals to 6. So therefore, we can bring them together so that we can solve them either using the earlier explained methods. We have elimination method, we have substitution method, we have matrix method, and still, as well as we have graphical method. So we are going to use it because the earlier one we are done using, or if you watch the other video we use this the elimination method. Now I want us to use the substitution method. So when you have this one, you can as well arrange it so that it can run with the other one. So we have y plus x, we will get answer to be 10. So we have two equations there. So can we use this we are going to use the substitution method. Substitution method, you can use the first equation, then we substitute the second equation, whereby we have y minus x is equals to 6. So we can as well take this 6, we make y to be the subject, so that when we say y is equals to 6, then this one goes there, it is now having a minus. As we had explained, when it goes equal sign, it becomes a minus, it becomes a plus. So it is plus x. So this one will go on the equation where there is y in the second equation, and the second equation is this one. So we'll have y, and our y is now this one. Our y is now this one. So we'll take 6 plus x plus now this x is equals to our 10 there. So what do we do? So we have x plus x plus x is the same as 2x. So we have plus 2x is equals to 10. What do you do? Collect like terms. So 6 goes to the other side, becomes only the 2x is equals to 10 minus 6. So 2x will be equals to 10 minus 6. It is supposed to be 4. So when you divide both sides by 2, you get what? You get x alone is equals to 2 goes here, 1 goes here, 2. So our x was 2. Our x is 2. Now, if our x is 2, using the equation, now we can as well substitute. Not like unlike the elimination where we must eliminate. We eliminate the first one, again we write the question, we eliminate again. So in this case, we just, if we're getting this, we just substitute it in one of the equations. So we have y minus x is equals to 6. You can use as well this. So where there is x, I put 2. So therefore, y minus x. Our x is 2. So y minus 2 is equal to 6. What do? We take this minus to the other side. So we'll have y alone is equal to 6, where here we have a minus, when it goes there, it becomes what? A positive. So our y will be equal to 6 plus 2 will be 8. Now, therefore, x is equal to 2, y is equal to 8. These are not the answer. They are saying find the number. The number, these are just the values of x. But remember, our number was x, y. Therefore, for us to get the y, what is the value? Now, where there is x, we put 2. Where there is y, we put 8. Therefore, our original number was x, y. Therefore, x is 2 and y is 8. Therefore, our number was 28. We can confirm by saying 2 plus 8. When we add the 2 plus 8, we get 10. We will be saying a 2-digit number is such that the sum of the unit digit, that is 2, and the 10th digit is 10. So 2 plus 8 is 10.